Hello and welcome to Module 8 Activity 2, the Hydrostatic Servo Control. In this activity we're going to be connecting the microbit to a potentiometer on the right hand side and a servo motor, and the control of the potentiometer will allow the servo to speed up and slow down. When we're looking at connecting all of this to the board, very simple. The servo here on the right hand or the left hand side can be connected using the terminal blocks and the pins here on the board. On the right hand side you'll see here that the potentiometer is connected, the three pins are connected to the pads that we see on the right hand side of the board. Similarly to the previous activity, the terminal block for the power with the PP3 is connected to the battery here. But as you can see here, it states in the text that the ground is the outside leg is connected to G and D. The other outside leg is connected to 3 volts to get the power, and then the middle leg is connected to P1. It could also be connected to P2 or P0 in order to receive a signal. As we've highlighted in previous modules and previous activities, that the P0, P1 and P2 are analog inputs, so therefore they can read variance in signal. The outside and the inside leg, it does not matter which one is connected to ground or 3 volts, it just means the operation of the potentiometer will work oppositely. So therefore, in one instance, spinning it to the right will increase the resistance, and if you connect it the opposite way, spinning it to the left will increase the resistance. But the key part of all of this is that central leg is definitely connected to P0, P1 or P2 in order to send a signal to the microbit. So once again, using Keyquil's model of planning, we need to take a look at engaging with the code. Here we need to plan the code, understand the problem, challenge or what information needs to be solved. We need to use the code, such as the blocks that we need to develop this up. Then we need to test it and determine if the solution is effective. And if we can find a better way, you can see again that iterative loop, go back to replan, recode, retest it, and then same again if you find a better way after that. The final stage is to download and apply it to the code and bring that solution to life. So first of all, let's take a look at understanding the problem. And what is the problem? Well, we want to control the speed of a servo using a potentiometer. What code will we be using, or what blocks will we use to make this happen? Well, first of all, we'll be using the basic in order to control this forever. We're also going to be using the robotics in order to make the servo move. We're going to be using the variables, so in order to give the different value coming from the potentiometer. And then the last bit, then we need to use the pins in order to use the map and create a scenario depending on max resistance and least resistance. Now, looking at the make code blocks and looking what's happening here, as mentioned before, the basic is the blue one here and it's forever, so that means that this is going to happen in the background constantly. You can see here that this set potentiometer, the outside red block, is a variable, and that is the reading that's coming from the potentiometer here on the right hand side. So we've set the potentiometer, and then this inside red block is to map, and what that map means is it's going to take the reading from P1, so the pin that we've connected to the center of the potentiometer. It's going to take it. The readings that come from the potentiometer go from 0 to 180, and what we're going to do then is we're going to map it from a speed of 0 up to 180 degrees. Because if we remember from previous activities and previous modules, that that servos work in terms of speed and direction from 0 to 180. Now after that, then we're going to set the servo 1 to the reading coming from this variable, so from the potentiometer. Okay? So that's all we're going to engage with now, and we're going to take a look at that in action in terms of make code. Okay, so welcome to this part of the make code where we're going to engage with coding up the microbit here and make it work from start to finish. So first of all, the first thing we need to do is we need to introduce the forever block, which is in basic, and you can see we drop it out here. Now it's key to say that I haven't started a brand new module or a brand new activity here on make code, so therefore forever would automatically be there once I start it. But I am just starting from a new project, or from the middle of an old project, sorry, so forever it doesn't exist, so I need to add it in. The next thing I'm going to do is I'm going to go to variables. I'm going to click here on make variable, and as you can see before, I've done this previously before. Okay. So welcome to this part of the microbit piece, and what we're going to do is we're going to create this code in order to make the servo work due to the potentiometer. So first of all, I'm going to go to basic. I'm going to click here on forever, and I'm going to bring out the code here on the side. And as we would know from starting up a brand new project, forever should be on the screen for me, but this obviously indicates that I haven't started a brand new project. I've started from an old project I deleted. So I just need to find that one. Once again, it's a blue block, so it's basic and it's there for you forever. But if we'd started a brand new project, it'd be sitting there waiting for me. The next part of this is we need to create a variable, and this variable is going to be the potentiometer reading that's going to come in from spinning and rotating the potentiometer. So as you can see, click on variables, click on make a variable, and then call it whatever you would like. In this instance, I just called it potentiometer. You'll see then it creates 3 separate blocks: potentiometer, which can be used to add this into certain blocks and get the readings from it; the set the potentiometer to, which in this instance we're going to set it to the reading coming from the pin, the external pin, and then we can change the potentiometer value by a plus or a minus number, so that can be handy for creating loops or creating countdowns. But here I'm going to set the potentiometer to and drop it into the block. After that then I need to set the servo to a certain degrees, and I'm going to find that in the robotics tab and click on servos, and you can see here the first block for me is to set the servo 1 to a set degrees. Now the next part of this is I'm going to go back to that variables tab. I'm going to use this block that I said earlier I can use to create the value of potentiometer coming in. So there we go. So now what I've done is I've set the servo 1 to whatever the potentiometer tells it to be. Okay. So the last part of this whole thing, and as you can see it's quite a quick and simple setup once we know what's happening, but what we need to do next is we need to set this value to coming from the actual spinning of the potentiometer itself. So I'm going to go here to the map, and the map function comes up a couple of different times in these activities, and it's quite a handy function. So I'm going to map from a value of 0 to 1023, and if you aren't aware, the potentiometer readings for the most part, fairly common, goes from 0 to 1023. Some of them might be a small bit more sensitive and mightn't go as high as 1023, and using the video on calibrating sensors and calibrating this, you might be able to see how this works. That's available in the learning log, and it's definitely available on the module there where it talks about the calibrating through the video. The video is available on page 26, which is accompanying this activity. So when we take a look back on what we're trying to do here, we're trying to get the value from the potentiometer from a 0 up as high as it's willing to give us. The next thing we're going to do is we're going to map it to a value of 0 degrees to, clicking on it there, 180 degrees. So I want this to go from the very bottom of the values of a servo to the very highest value of a servo. And then the last part of this whole code to finish it all off and get the reading from the pin is I need to go to this pins section, and you can see here analog read pin, and as I said in the previous section, P0, P1 and P2 are the 3 analog inputs that can take a varying resistance. So in this instance we're going to take it from P1, so I'm going to drop it in here, click on the P1, drop it down there, and now we have map analog read pin P1, and that can be taken, as I said, from the potentiometer being connected into P1. So just to go back over this again, it's saying forever, so that means that this isn't going to be controlled via button A's or button B's. It means it's going to happen all the time. It's setting the potentiometer to the value coming from the center pin of the potentiometer. It's going to take that from the lowest resistance that it has to the highest resistance, and it's going to map it to 0 to 180 degrees. And the last part of the block then states that it's going to set that servo to the value coming from the potentiometer in terms of degrees. So once again between 0 and 180. So what we're going to do next is we're going to move on to the real life section, and we're going to see this happening and how it's going to be connected in the next part.
So for module 8 activity B, the components that we need are our all-in-one robotics board, our continuous servo, our potentiometer and our microbit. Now when you're connecting your servo, ensure that it is the continuous servo that you choose. If it's the angular servo, it won't work right. Just in case the sticker is torn off your servo, if you check underneath, if it's the one that has the screw for adjustment on the bottom of it, you have your continuous servo. So continuous servo we're going to attach to servo connection 1 on our all-in-one robotics board. And again, just pay attention to make sure that you have the signal connected the right way around. So brown is always ground, and we're connected in on servo position 1. The code for module 8 activity B I have loaded into my microbit, which I'm now going to place into my all-in-one robotics board, ensuring that the front of the microbit faces towards the header pins. Now, to connect my potentiometer, my outside lug, in my case here it's coloured grey, is connected to the 3 volts. The outside lug on the opposite side, on the right, in my case here it's coloured blue, is connected to the ground. So I'm just going to hook those up now on my header pins on my all-in-one robotics board. There we go. And the important one, the wiper pin here in the centre, is going to be connected to pin 1, because that's what I have told my code it will be connected to. So my potentiometer is connected to my all-in-one robotics board. My continuous servo is connected to servo point 1. I'm now going to power up my all-in-one robotics board. I've got it powered with a 6-volt battery pack. When I power it up, I just need to be careful of catching the servo, because depending on what position my potentiometer is in, my servo may start moving around. So there's my continuous servo going at full speed in backwards direction. As I rotate my potentiometer, the servo will slow down until I get to the center position of the potentiometer, and my servo will be at a standstill. As I begin to move my potentiometer further forward, my servo begins to move very slowly. As I increase the potentiometer, the speed on the servo increases. And by using that piece of code, I can achieve a hydrostatic type or hydrostatic inspired effect, where I can have a variable speed forward and a variable speed backward using my continuous servo and my potentiometer to send a signal to my microbit.